All right, let's go ahead and learn how to draw Lewis formulas. Lewis formulas are pretty important to learn how to do. They tell us a little bit about the number of valence electrons in the molecule. They also tell us a little bit about the shape of the molecule in terms of what the central atom is and what the outside atom is. And they're going to be important when we do VSEPR. So it is kind of important that you learn how to do this right now. It's going to tell us a little bit about it. The first thing you need to make sure you do whenever you do a Lewis formula is follow the 4 rules or the 4 steps you see on the screen right now. It's important that you follow these 4 steps in sequential order. You really can't go out of order. Number 1 tells us that we need to calculate the total number of valence electrons. Of course, that's pretty easy to do. We've been doing that now for a little bit. All you have to do is go to the periodic table, check out the valence electrons for each element, add them together. We'll get to the positive and negative ions when we need to. Second step, draw a skeleton structure. It says to put the least electronegative atom in the center. And really what you need to do is look at your periodic table. Remember those elements that are furthest to the bottom and the left are going to be the least electronegative. Things close to fluorine are going to be highly electronegative, and they want to be on the outside. Third, distribute electrons to the outside, and any remaining go to the center. So let's go ahead and actually do one of these Lewis formulas for a compound. First one we're going to do is for SCl2, and the first step says that we want to go ahead and draw the total number of valence electrons, or calculate the total number of valence electrons. So on your periodic table, sulfur has 6. We have 2 chlorines. Each of those, of course, has 7, and that gives us a total of 20 electrons. That's important because when we draw our structure, our Lewis formula, we want to make sure we've accounted for all 20 of those valence electrons this thing has. Second step says to find the least electronegative and put it in the center. And this one's pretty simple to figure out the least electronegative. Sulfur is the least electronegative of the 2. Chlorine's something like the 3rd most electronegative, so we know it's not going to be the central atom. But that least electronegative goes in the center, and then connect it to the other atoms with bonds, like I've done there. The chlorines go on the outside. One of the things you want to remember is that a bond is really 2 electrons. So where did those 2 electrons come from? One came from the sulfur, one came from the chlorine. They're now being shared between the 2 atoms. Same with the bond on the other side. So of these 20 electrons that we're trying to account for, how many do we already have in our structure? Well, it looks like we've already got 4. 2 from this bond, 2 from this bond. So we've got 16 more we need to account for. Next step says, once you've got your skeleton structure, go ahead and start distributing electrons to the outside atoms, which in this case are the 2 chlorines. How many do you distribute? Well, we're going to distribute until we get to that octet. So remember, chlorine already has 2 associated with this bond, so let's give it 6 more. 3 pairs of 2. Always distribute in pairs. This chlorine over here is going to look exactly the same. It's already got 2 from the bond, so let's distribute 3 pairs of electrons. Each of those chlorines now has its octet. Sometimes it's a good idea just to stop after each step and make sure you or check how many electrons you have. In this case, let's see, we have 2, 4, 6, 8, 10, 12, 14, 16. And remember, we're shooting for 20 valence electrons, so we still have 4 more now we need to account for. Last step says distribute to the central atom, which in this case is sulfur, which already had 4 electrons. Why? 2 from this bond, 2 from this bond. So let's give it 4 more. And that would be 2 pairs of 2. Always distribute in pairs. You can see this thing now has 20 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've accounted for the 20 electrons that we know we needed in this particular structure. And that's how you draw a Lewis formula. What I want you to do is go ahead and try the POCl3 molecule, see what you can come up with that one. Remember, count the total number of valence electrons, get that least electronegative atom to put in the center, put all the other ones around it, distribute the electrons to the outside, distribute them to the inside, and see if you can come up with the correct structure before you watch the second part of this video.